Hello guys, welcome to Ramsai Ias, the final part of time, speed, distance. In this video, we are going to solve few problems on boats and streams. But don't forget to watch introduction on boats and streams before watching this video. Okay, let me give you a brief of boats and streams. Okay, always water flows from top to bottom, up to down, you can say. Okay, this is up and this is down. A boat's speed in still water is represented by U and water speed is V. Okay, when the boat is traveling from up to down, we call it as downstream speed and it is represented by A. This downstream speed is equal to the speed of boat and water U plus V. When the boat is traveling from down to up, we call it as upstream speed and it is represented by B, which is U minus V. So, I will write the two equations here. A equal to U plus V, B equal to U minus V. And if you can solve these two equations, U will be half of A plus B and V will be half of A minus V. Guys, remember the total concept of boats and streams depends on these four equations only. Hope it is clear. We will start with the first question. A boat can row upstream at 10 km per hour and the downstream at 20 km per hour. What is the speed of the boat in still water? Guys, remember always downstream speed will be higher than upstream speed and speed of boat will be more than speed of water. Okay, now a boat can row upstream. Upstream means you can write it as B at 10 km per hour and downstream speed A equal to 20 km per hour. What is speed of boat in still water? So, U equal to what? U is half of A plus B. So, half of 10 plus 20 is 15 km per hour, which is in option D. Right? Next one. A man can row down the stream at 20 km per hour and speed of flow is 8 km per hour. What is the speed of the man against the stream? So, here downstream speed is represented by A. Downstream speed is A. A equal to 20 km per hour. And here stream speed, speed of flow is nothing but stream speed is 8 km per hour. And we need to find out what? What is the speed of the man against the current? B equal to dash. Okay. We know the formula V equal to half of A minus B. Substitute here, you will get the answer. V equal to 8 and this 8 equal to half of A minus B, 20 minus B. B we need to find out, right? If I take 20 to this side, it will be 8 into 2, 16. So, B equal to 20 minus 16, that equal to 4 km per hour. So, option D, 4 km per hour will be the answer. The next one, the speed of boat is 20 km per hour against the current and it is 30 km per hour with the current. So, in the introduction, I already told you, with the current means it is downstream speed. With the current, A equal to 30 km per hour and B against the current is 20 km per hour. And we need to find out what is the speed of the flow. Water speed is dash. V equal to half of A minus B. A minus B is 10. 10 by 2. E will be 5. So, 5 km per hour will be the answer. Right? The next one. A boat can row 3 kilometers up the stream in 36 minutes and down the stream in 18 minutes. What is the speed of the boat in still water? Fine. Here the distance was given from up to down. This 3 kilometers. Okay, to travel the 3 kilometers in the two ways, find out A value and B value so that you can get the boat speed in still water. U equal to half of A plus B. Here, what is A? Time taken, not time taken. A is the speed in downstream. When it is coming down, total 3 kilometers it covered in 18 minutes itself. But convert these minutes into hours by dividing with 60. Plus 3 kilometers in 36 minutes. Convert this into hours. So, if I take these 360s to the numerator, it will be half of 63s are 180, 63s are 180. 180 by 18 plus 180 by 36. So it will be 10, it will be 5. So 10 plus 5 is 15 upon 2. So 15 by 2, it will be 7.5 kilometer per hour. So option C, 7.5 kilometer per hour will be the answer. The next one. The speed of boat in still water is 25 km per hour and the speed of the flow is 5 km per hour. The boat travels from A to B down the stream and returns the same distance in 5 hours. Then what is the distance between A and B? Just imagine the distance between A and B is d kilometers. D kilometers, the distance between A and B. So this is downstream and this is upstream. And the speed of boat in still water is 25 kilometers and the speed of flow is 5 kilometers. So when they are going down, A equal to 25 plus 5, 30 kilometer per hour, and when it is coming up, it will be 25 minus 5, 20 kilometer per hour. It represents by B. Then what is the distance between A and B? We need to find out, right? Here the boat travels from A to B downstream and returns in 5 hours. So I'll do one thing. I'll find out the time taken to travel from A to B and B to A separately. So from A to B takes d kilometers with a speed of 30 km per hour, and return B to A, it travels the same d distance with a speed of 20 km per hour. Distance by speed gives you time period, no? And for the overall journey from A to B and B to A, it takes 5 hours. So now we have only one unknown. With one equation, you can solve the problem. So LCM of 30 and 20 is 60, 62s, 23s equal to 5. From this I can write 2d plus 3d gives you 5d. 5d equal to 5 into 60. I'll take the 60 to right side. Now 5 and 5 gets cancelled. You will remain with d equal to 60. So 60 kilometers will be the answer. Hope it is clear. The next question. The speed of boat in still water is 8 km per hour. It takes the boat thrice as long to row up the stream as to row the downstream. What is the speed of the stream? Okay, here we have given the speed of boat in still water and the ratio of time taken for downstream and upstream. Then we need to find out V value. Okay, but we know the relation between speed and time taken, and it is the inverse relation, right? So do you remember this? Speed of first and second objects ratio will be the ratio of time taken by the second object and first object. The inverse relation between speed and time can be represented like this. And now when a boat is rowing from up to down, its speed will be u plus v, and while coming up from down to up, its speed will be u minus v, right? And in the question, u value was given as 8 kilometers per hour and we will use it later, okay? And it takes the boat thrice as long to row up than the down. So just imagine, if it takes t hours while going down, it will take 3 t hours while coming up. Now by using this inverse relation with the given data, we can solve the problem like this. Speeds u plus v is to u minus v will be equal to reverse of this 3t is to t. Inverse relation, u plus v is to u minus v equal to reverse of time, 3t is to t. Now the tt gets cancelled, it will be 1. Do cross multiplication. U minus v equal to 3 of u minus v. This is u plus v equal to 3 of u minus v. Now take this v to left side and u to right side. V minus 3 becomes plus 3 here. So 4v equal to 3 minus 1 to u. And from the question, u equal to 8 kilometers. Let me substitute u value here in the final step. V equal to 2 into 8, 4 2s are 8, 2 into 2 equal to 4 kilometer per hour, and the value V, the speed of stream, equal to 4 kilometer per hour, which is in option B. Guys, remember this black color and black color explanation and this relation is very, very important. Okay, fine. Next question. The boat can row 24 kilometers down the stream in 4 hours. If the speed of the flow is 2 kilometers per hour, find the time required for the boat to travel the same distance against the current. Fine. The boat can row 24 kilometers down the stream in 4 hours means, what is the formula? When it is going down, speed will be u plus v. Speed into time gives you distance. So from this we can write u plus v equal to 4 6s are 24. But from the question, v equal to 2 kilometer per hour, substitute here, then u will be 6 minus 2, 4 kilometer per hour. Now when the boat is going against the current in the upward direction, the speed will be u minus v, then 4 minus 2, it will be 2 kilometer per hour. Now to travel the same distance of 24 kilometers, how much time it will take? Time equal to distance by speed 2 kilometers per hour. It will take total 12 hours. Can you find 12 hours in options? Yes, option B, 12 hours is the answer. And the final question in this video. A man takes half time in rowing a certain distance downstream than upstream. So what is the ratio of the speeds in the still water to the speed of current? So it is a bit similar to the previous question, just before question of the previous one, right? Now what is the relation between speed and time? Yes, inverse relation. I'll write it again. S1 is to S2 equal to T2 is to T1, right? When a boat is traveling from up to down, speed will be u plus v, while coming up it will be u minus v. And from the question, a man takes half time in rowing a distance downstream than upstream means when he is coming upstream, he will take the double of the downstream, right? So just imagine if he takes t hours while going down, he will take 2t hours while coming up. That is what given in the question, right? Half of the upstream time, right? Now by using this relation, I can write u plus v by u minus v equal to inverse of the time 2t by t. T gets cancelled and do cross multiplication. It will be u plus v equal to 2u minus 2v. Now take this u to right side and v to left side. Then 3v equal to 2u minus u, that equal to u. Now tell me what is the ratio of u and v. U and v equal to, if I take this v this side, it will be 3:1. So answer is 3:1, which is in option D. Now don't get confused, it cannot be 1:3 because always speed of boat in still water will be greater than the speed of current. So always u should be greater than v. So answer must be 3:1 only.